For our week 1 review, we'll look at 4 types of problems that were the most missed on the homework this week. First, we'll look at how to factor expressions that have rational exponents. We'll look at equations in one variable, solving rational equations, and then we'll look at one example of a linear word problem. We'll be factoring out a greatest common factor, which means we're looking for an expression that is the largest expression that will divide into all of the terms that we have. So when we look at the two terms, 12x to the fifth minus 18x squared, and we look at the number parts of those terms, we see a 12 and an 18, and the largest number that divides into both 12 and 18 is 6. For the variables, x to the fifth and x squared, the most x's those two terms have in common is 2 factors of x. So x squared will also be in our greatest common factor. That means that we can factor out or divide out a 6x squared from both of the terms. We'll write that greatest common factor down, and then that will multiply the leftover factors that we get when we divide each of these terms by 6x squared. One way to think of that is to literally think about what you would get if you would divide the terms by that greatest common factor. So if we would divide 12x to the fifth by 6x squared, 12 divided by 6 is 2, and x to the fifth divided by x squared is x to the third power. There's a couple of ways to think of that. One is to say there's 5 factors of x in the numerator, 2 factors of x in the denominator. The 2 factors of x in the denominator would cancel out with 2 of the 5 factors of x in the numerator, leaving us with 3 factors of x, or x cubed. You could also use exponent rules, and that might be a little bit better to think of it that way as we move forward to these fractional exponent problems. If you say 5 minus 2 is 3, that gets you the exponent on the x to the third. And then for the minus 18x squared, if we think about what that would look like if we divided it by the greatest common factor, the 6x squared, negative 18 divided by 6 is negative 3, and then x squared divided by x squared is 1, so negative 3 times 1 is negative 3. So now we've got the factored form of our original polynomial. Now everything we just did with that expression, we're going to do with the expression that we see with fractional exponents. So for 15x to the 5/4 plus 30x to the 3/4, we'll look for the greatest common factor, meaning what's the largest monomial that divides into both of these. For the 15 and 30, the largest number that divides into both of those is the 15. And then for the x to the 5/4 and the x to the 3/4, we can take a hint from what we did in the previous problem and notice that the greatest common factor for the variable factors was whatever the lowest exponent factor was. So in the previous example, the x squared was the lower exponent between the x to the fifth and the x squared. For x to the 5/4 and x to the 3/4, the lower exponent is the 3/4. So the x to the 3/4 is going to be in our greatest common factor. So when we factor this expression, we'll have a common factor of 15 x to the 3/4 times the leftover factors. To figure out the leftover factors, we can take each of these factors and divide them, or each of the terms I should say, and divide them by the greatest common factor. So if we take 15x to the 5/4 and divide it by that greatest common factor of 15x to the 3/4, 15 divided by 15 is 1. And then the x to the 5/4 divided by x to the 3/4, we could subtract the exponents. So 5/4 minus 3/4 is 2/4. We've got a common denominator, so that's an easy subtraction to do. 5/4 minus 3/4 is 2/4, and 2/4 does simplify to 1/2. So we can write that as x instead of 1x, x to the 1/2 power. And then for the 30x to the 3/4, we're taking the 30x to the 3/4 and we are factoring out, dividing out our greatest common factor of 15x to the 3/4. 30 divided by 15 is 2. And then x to the 3/4 divided by x to the 3/4 is 1. And 2 times 1 is 2. So there's our factored form. 15x to the 3/4 times x to the 1/2 plus 2. Now let's do one more with fractional exponents. 4x to the negative 5/4 plus 6x to the 1/4. So let's find the greatest common factor first. Starting with the number factors, we've got a 4 and a 6, and the largest number that divides into that is 2. For the variable factors, we've got x to the negative 5/4 and x to the 1/4. We're looking for the smallest exponent. That's the negative 5/4. So x to the negative 5/4 will also be in our greatest common factor. So we know we can rewrite this as that greatest common factor, 2x to the negative 5/4 times some binomial. To get the binomial, we'll look at each of the terms and divide by the greatest common factor. So 4x to the negative 5/4 divided by a greatest common factor, 2x to the negative 5/4. Well, 4 divided by 2 is 2. And x to the negative 5/4 divided by itself is 1. So that's 2 times 1, which is 2. And then for the second term, we have a 6x to the 1/4. We're dividing that by 2x to the negative 5/4. So for the number factor, 6 divided by 2 is 3. And then for the variable factors, because we're dividing and the bases are the same, bases are both x's, we're going to subtract the exponents to get the new exponent on the x. So if we look at the exponent in the numerator, 1/4 minus the exponent in the denominator, negative 5/4. That's the same thing as 1/4 plus 5/4, which is 6/4, and we can call that 3/2. Remember, this is the exponent on the x. So 3x to the 3/2 is our second term in the parentheses. Now we've only got one more thing we're going to do, and I've kind of run out of room here, so I'm going to bring it down here. If you'll notice, we've got a negative exponent on this factor in our greatest common factor, and that's not considered simplified. So we're going to use one of our properties of exponents that says when we have a negative exponent, we can rewrite that using a reciprocal. So the x to the negative 5/4, that factor, we're going to reciprocate by pulling that factor down to the denominator of a fraction, and that's going to give it a positive exponent of positive 5/4. The 2 does not have the negative exponent on it. It's going to stay in the numerator. And then we have the other factor, the binomial, which is also going to stay in the numerator. 2 plus 3x to the 3/2 power. The next thing we're going to look at is solving equations. And we're going to start with a fairly simple one. Remember, solving means looking for a number or numbers that we could substitute in the equation for the variable to make a true statement. So for this one, we can see that we have a distributive property that's happening on the left side. So we'll go ahead and do that. 3 times 2x is 6x, and 3 times negative 5 is negative 15. So 6x minus 15 is negative 5x. Now we want to get all our variable terms on one side of the equation, all our number terms on the other. It doesn't matter which side we put the variable terms or the number terms on, as long as we have like terms collected on each side of the equation. So I think what I'm going to do is get the variable terms on the left side, number terms on the right. It's going to take me an extra step, but I think it's what most of you probably would lean toward doing. So let's add 15 to both sides of this equation so that we've got the number terms on the right side. So negative 15 plus 15 is 0. On the left side, 6x plus 0 is just 6x. On the right side, we have negative 5x plus 15. Now to get our variable terms together on the left side, we'll add 5x to both sides. 6x plus 5x is 11x. The negative 5x plus 5x, that adds to 0, and 0 plus 15 is 15. And then 11 is multiplying the x. We want to isolate that x, so we'll divide both sides by the 11, and we get x equals 15/11. Now there's no need to change that to a decimal. I suppose we could write it as a mixed number if we wanted to. It's simplified already. There's nothing that divides into both 15 and 11, so I'm going to leave it as the improper fraction, 15/11. Okay, let's try another one. Now the basic steps that we just saw are not going to change. We're still going to ultimately want to get all the variable terms on one side, all the number terms on the other side of the equation. We might have to do a little bit of work before we get to that point though. For example, we've got a distributive property going on in this equation as well. So let's go ahead and distribute. 4x minus 2 times 3x, that's negative 6x, minus 2 times negative 1, that's positive 2, equals 5 minus 2x. Let's go ahead and combine the like terms on the left side. So 4x minus 6x is negative 2x, plus 2 equals the 5 minus 2x. Now we've got everything combined that we possibly can on the left and the right, so let's see what we can do about getting all of our variables on one side and all of our numbers on the other. I'm going to move the number terms to the right side again, so let's subtract this 2 from both sides. We'll have negative 2x plus 0, that's just negative 2x, equals 5 minus 2 is 3 minus 2x. Now I want to get rid of this variable term on the right side, so I can add 2x to both sides. On the left side, negative 2x plus 2x, those are opposites, which add to give us 0. And then on the right side, we've got 3 minus 2x plus 2x, once again, is 0. So 3 plus 0 is 3. And all the variables disappeared. So if all the variables disappear, that means that we have to think about this number statement that we've been given, which says 0 equals 3. 0 doesn't equal 3. That's a false statement. If you get a false statement, that means no matter what number we'd put in here for x, we could never get a true statement. So we're going to have no solution. And a way that we can write no solution is with the empty set symbol. So absolutely no number will make this equation true. There is no solution. Okay, let's try this one. The steps actually do not change. We're going to simplify each side as much as we can, try to get the variables together on one side, numbers on the other, and then in the end solve for x by isolating the x. So let's see what we can do on the left side. We've got a negative 4 multiplying this binomial, so negative 4 times 2x is negative 8x. Negative 4 times 1 is negative 4. And we've got a 3 we can distribute. So 3 times x is 3x. 3 times 8 is 24. And on the right side, more distributive property. We've got 5 times 4 is 20. 5 times negative x, that's minus 5x. All right, let's combine like terms on the left side. So I see negative 8x plus 3x, that's negative 5x. And then for the number terms, I see negative 4 plus 24, that's plus 20. Equals, not much to do on the right side, 20 minus 5x. All right, let's get all of our numbers to the right side. So I'm going to subtract this 20 from the left side and the right side. That gives us negative 5x equals, let's see, 20 minus 20 is 0. Minus 5x is minus 5x. 5x. Interesting. Let's add 5x to both sides. We're trying to get all the variables together on the left side. So on the right side, minus 5x plus 5x, those are opposites. Opposites add to give us 0. Same thing's happening on the left side. Negative 5x plus 5x, those are opposites. They add to give us 0. So once again, all the variables have disappeared. We just have numbers. 0 equals 0. That is definitely a true statement. If you get a true statement, something that's always true, that means no matter what number we'd put in this equation for the x, the equation would be true. And there's an infinite number of numbers in this world. So there's an infinite number of solutions to this equation. Infinite solutions. So no matter what number we would put in this equation for x, the equation would be true. So we've got a nice strategy for solving equations, but what do you do if your equation has fractions? Fractions just kind of complicate the way the equation looks. So we do have a way to get rid of those fractions in the equation. What we're going to do is look in our equation for whatever the least common denominator is of all the fractions that we notice in the equation. So for this equation, 5/3 x minus 1 equals 4 plus 2/3 x. The fractions are 5/3 and 2/3. So the least common denominator between those two fractions is 3. They have the same denominator of 3. So here's the trick. We know that we can keep a balanced equation if we multiply both sides of the equation by the same number. We're just going to choose to multiply both sides of the equation by that least common denominator of 3. So we'll take 3 times the left side of the equation, and that has to equal 3 times the right side of the equation. You've still got a balanced equation because we multiplied both sides of the equation by the same thing. Now for a moment, this is going to look more complicated than it was to begin with, but you've got to trust me, this will get rid of the fractions. We're going to need to distribute this 3. So we will have to multiply the 3 times the 5/3 x. We'll have to multiply the 3 times the 1. And then on the right side, we'll have to distribute. So we'll have to multiply the 3 times the 4 and the 3 times the 2/3 x. Now what I'd like you to notice is that at this step, what this looks like is every term that we started with being multiplied by the least common denominator. Now for every single fraction, or every single term, we can simplify the fractions. In this first term, we've got 3 times 5/3, so these 3's would cancel, and that would leave us with 5x. Second term, minus 3 times 1, that's minus 3. On the right side, 3 times 4 is 12. And then in the last term, the 3's would cancel, and that would leave us with 2x. So just like that, the fractions are gone. And now we're just going to get the variables on one side, numbers on the other. So we'll add 3 to both sides, and we'll have 5x equals 18 plus 2x. We'll subtract the 2x from both sides. I'm running out of room, so I'm going to continue this over here. 5x minus 2x is 3x. And then 18 is our number term on the right side, and then we'll divide both sides by 3, and we get x equals 6 for our solution. So it's kind of a nice little trick. Multiply both sides of the equation by the least common denominator of all the fractions in the equation, and you will no longer have fractions to worry about. If you look at these fractions and look at the denominators, you might notice that the denominator on the right side can be factored. If you notice that, you want to go ahead and factor all your denominators before you try to find the least common denominator. So x squared minus 16, I'm just going to write it below this, I know is x plus 4 times x minus 4. Now that's helpful in finding the least common denominator, because what I can see in looking at all these fractions is that they all have a some of them anyway, have a factor of x plus 4, And I also notice that there's a factor of x minus 4 in the denominators. So my least common denominator is x plus 4 times x minus 4. Now let's multiply every term by that least common denominator. So we'll multiply x plus 4 and x minus 4 times the first fraction. We'll multiply x plus 4 and x minus 4 times the second fraction. And we'll multiply x plus 4 and x minus 4 times the fraction on the right. And I'm going to go ahead and write it as 3x plus 8 over x plus 4 times x minus 4 because that's what that denominator factored into. Now here's where the magic happens. All of our denominators are going to cancel out now. In the first term it's the x plus 4's that cancel out, and that leaves us with 1 times x minus 4. In the second term it's the x minus 4's that cancel, and that leaves us with 3 times x plus 4. And on the right side, the x plus 4's and the x minus 4's cancel, and that leaves us with 3x plus 8. So you can see in the step before this, it looks messy, but it's all worth it because our denominators cancel out. Okay, so let's distribute. 1 times x minus 4 is x minus 4. 3 times the x plus 4 is 3x plus 12 equals 3x plus 8. Combining like terms on the left side, x plus 3x is 4x. Negative 4 plus 12 is 8 equals 3x plus 8 on the right side. Let's get our numbers to the right. So I'll subtract the 8 from both sides. And we'll have 4x plus 0, so that's just 4x equals 3x plus 0, that's just 3x. Let's subtract the 3x from both sides. Trying to get all the variables on the left side. I'll bring it up here because I'm running out of room. So 4x minus 3x is x. And then on the right side, 3x minus 3x, anything minus itself is 0. So we get x equals 0 for our solution. Now there's one last thing we need to check for. Remember, these were fractions that had variables in the denominator. So we've got to double check something. We've got to make sure that that number 0, which is a possible solution, does not make any denominator 0. Numbers that make denominator 0 are called restrictions on the variable. So let's check for those. There's two places to look at for restrictions. You've got your choice. One is you can look back at the original fractions in the original problem and think, well, what makes each of these denominators 0? Or if you've got your least common denominator written down, you can look at that as well. So what makes x plus 4 0? That would be negative 4. And what makes x minus 4 0? Well, that would be positive 4. So that means we can never let x be negative 4 or positive 4. And if we check our possible solution, which was 0, that's fine. It's not a restriction, so x equals 0 is definitely a solution. Okay, let's try one more equation that has fractions in it. So 2x over 2x plus 3 plus 6 over 4x plus 6 equals 5. Make sure you're not tempted to cancel out these 2x's, by the way. The 2x in the denominator isn't a factor, it's a term. It's connected to the rest of what you see down here with a plus, not a times. So we can't do any canceling here. But we can go through the same steps we did in the last problem, finding the least common denominator, multiplying everything through by that, and that will get rid of our denominators. Before we do that, it would be really helpful to factor this second denominator. So 4x plus 6 is the same thing as 2 times 2x plus 3. All right, so what are the factors that we see in our denominators? We definitely have a 2x plus 3. And what else do we see? Definitely have a factor of 2. That's coming from the second fraction. So our least common denominator is 2 times 2x plus 3. Let's multiply every term that we see on both sides by that least common denominator. So 2 times 2x plus 3 times the first fraction, 2x over 2x plus 3 plus 2 times 2x plus 3 times the second fraction, 6 over 2 times 2x plus 3. Notice I'm writing that in factored form. Equals 2 times 2x plus 3 times the right side, which is just a 5. All right, so in the first term, 2x plus 3's do cancel. That leaves us with 2 times 2x. Second term, the 2 cancels. The 2x plus 3 cancels. That leaves us with a plus 6. And then on the right side, we've got a 2 times 2x plus 3 times 5. Nothing cancels. 2 times 5 is 10 times the 2x plus 3. All right, so let's keep simplifying each side. 2 times 2x on the left side is 4x plus 6 equals, and then we'll distribute here. 10 times 2x is 20x. 10 times 3 is 30. All right, let's get the variables on the left, so we'll subtract 20x from both sides. 4x minus 20x is negative 16x. Plus the 6 equals 30. Subtract the 6 from both sides. Bring it up here. That gives us negative 16x equals, let's see, 30 minus 6 is positive 24. And then divide both sides by that negative 16. So we get x equals, let's see, what divides into both 24 and negative 16? How about an 8? So 24 divided by 8 is 3, and negative 16 divided by 8 is negative 2, so we get negative 3/2. Now the one thing we haven't checked for is that a restriction on the variable? So let's go back up to our least common denominator and think about what the restrictions are. Restrictions are numbers that make any denominator 0. And that means we can look at the factors in the least common denominator and think about what numbers for x would make them 0. Well, 2 isn't a 0. 2 is a 2, so that's not a problem. 2x plus 3, we can never let that be 0. So 2x plus 3 cannot be 0, which means, let's see, subtract 3 from both sides there. 2x cannot be negative 3. Divide by 2, so x cannot be negative 3/2. Oops, that is a problem. Negative 3/2 is what we came up with as a possible solution, but it's a restriction, which means although we did everything right here to get negative 3/2 as a possible solution, we've got to throw it out. So our solution is no solution. There's no number that will make this equation true. For the last problem, I want to look at one word problem. Now there is a whole world of word problems. I just want to look at an example of kind of the thinking process that's helpful to go through when you're solving a word problem. This one is a coffee shop charges $3.50 a cup for coffee. Patrons can also buy a Super Sipper membership for $30. With the membership, each cup costs only $1. How many cups of coffee must be purchased to make the membership a better buy? So obviously the membership isn't worth your while if you're not going to buy much coffee. I mean, if you paid $30 for the membership and only bought 1 cup of coffee, that 1 cup of coffee would cost you, what, $30 plus another dollar, would cost you $31, as opposed to not buying the membership and just buying the cup of coffee for $3.50. So there's going to be some point that's a break-even point where it costs exactly the same to have the membership versus not having the membership. And the cost, the total cost, is dependent upon how many cups of coffee you buy. So that's an indication of what our variable needs to represent. The thing that's going to change. That's why it's called a variable. It can change. It can vary. So we're going to let X be the number of cups purchased. So number of cups. All right, so if X is the number of cups purchased, and we're going to look for that break-even point, we're going to look for the cost without the membership and the cost with the membership. And what we're going to ask ourselves is how many cups, I should say, would we need to purchase to make those two costs the same? So when do these costs equal to each other? I'll put a question mark up there because I don't know when that happens. So without the membership, we would be purchasing cups of coffee. Every cup would cost us $3.50. So the cost without membership, if we buy X cups of coffee, is $3.50 times however many cups of coffee we buy. So $3.50 times X. And then with the membership, the cost would be the cost of the membership, which is $30, plus $1 for every cup of coffee we buy. So we've got our equation to solve. 3.50x equals 30 plus 1x. So we're going to go through the same process with the other equations. We're going to get the variables on one side, numbers on the other. So we can subtract this 1x from both sides. 3.5x minus 1x is 2.5x. I could put the 0 on the end of that, but I'm not going to. Equals 30. And then we'll divide both sides by the 2.5 to solve for x. Now remember, you can't use a calculator in this course. So how do we deal with the 30 divided by 2.5 when we don't have a calculator? Well, one trick I'm going to use is we're dividing by decimals, a little bit messy. So how about if we multiply numerator and denominator of this fraction by a 10? If we do that, in the denominator, 2.5 times 10 just moves that decimal point over one place. That's 25. And then 30 times 10 is 300. And then I'll look for something that divides into both 30 and 25. I'm thinking 5 is a good choice. 300 divided by 5. 30 divided by 5 is 6, so 300 divided by 5 is 60. And 25 divided by 5 is 5, and 60 divided by 5 is 12. So the cost is the same for 12 cups. If you want to pay less overall, you'd have to buy more than 12 cups.